Picture a construction site so high in the mountains that no truck can reach it. There's no road to the top. There's no way to assemble a crane up there. And cutting through the forest to make space would destroy land that's supposed to stay protected. Then 16 heavy lift drones rise from below, carrying steel and concrete straight up the cliffs. As if the mountains simply stopped being a problem. Over 3 days, China moved 180 tons of material entirely through the air. So are drones really turning into flying cranes? And why does America suddenly look stuck on the ground? What's actually happening? The viral version of this story makes it look like China is using drones to lift entire tower cranes and drop them onto buildings. It's a dramatic image, but it's not true. A fully built tower crane, with its base and counterweights included, is far too heavy for any drone to lift. What's actually happening is simpler than that, and in some ways more important. The job a crane usually does is being split into smaller pieces and flown in one load at a time, until the site no longer needs to be reached the old way. That changes the first challenge of any construction project. The hardest part usually isn't building the structure itself. It's getting to the place where it needs to be built. A tower on a mountain needs a road for vehicles. A remote power line needs workers to climb dangerous terrain. A site inside a protected forest forces a choice between slow access or environmental damage. Heavy lift drones solve that problem before it ever becomes a road, a cable system, or weeks of preparation. If materials can simply fly to where they're needed, a huge part of traditional construction work disappears. These aren't small hobby drones. They're built to carry serious industrial loads. The Skytech S400 Plus, designed for power grid projects, has 12 propellers across 6 arms and can lift hundreds of kilograms at once. The United Aircraft TD550D is an unmanned helicopter that keeps its lifting power even at high altitude, where most aircraft start to struggle. Then there's DJI's Flycart 100, which uses a winch to lower cargo with smooth control, instead of making workers catch heavy loads from the ground. That winch feature matters more than it sounds. A normal delivery drone just moves something from one point to another. A construction drone has a harder job. It has to carry a load to an exact spot, hold steady in the air, lower it carefully, and set it down without swinging into a person, a wire, or a rock. That's the moment this stops being simple delivery. The drone starts acting like a small crane in the sky. And once a group of drones can repeat that all day, a mountain stops being an obstacle and becomes just another location to fly to. The proof? In Yunnan. The clearest example of this happened in Yunnan province. In May 2025, a team needed to build high-voltage power towers in Shisun County, an area surrounded by steep limestone peaks and protected rainforest. Normal construction methods were almost impossible there. To make it harder, the site sat inside a route used by migrating elephants. So even building a simple access road would have caused a new problem before construction even began. The usual approach would have meant weeks of work and serious damage to the land. Instead, the team used drones. 16 heavy lift drones made repeated trips into the mountains, carrying steel parts, concrete, and rigging equipment to each tower location with precise control. Over 3 days, they moved about 180 tons of material in total. That number is impressive, but the real story is what the project avoided. No trucks meant no need to clear the forest. No cableway had to be built first. Everything the site needed came from the air, and the ground below stayed mostly untouched. This matters far beyond one viral video. It showed that a power grid project could be built without leaving the usual marks behind, like roads, work zones, fuel trucks, and tire tracks. In Yunnan, the materials simply arrived from above. The drones became the supply route itself. If this becomes common, building in remote places stops being a fight against difficult land and becomes a simple matter of flight scheduling. removing the dangerous job. A year later, a second case showed why this technology matters even for routine maintenance, not just new construction. In Xinjiang, a crew needed to reach a transmission tower across a rough river and an unstable slope. The old method meant carrying tools and equipment by hand across dangerous ground, a trip that could take hours each way. Using a Flycart 100, the same delivery took just 2 flights and finished in under 30 minutes. Saving that time was useful, but the bigger win was safety. The drone took on the exact part of the job most likely to hurt someone. A different challenge came up in Hubei province. During a harsh winter in Shennongjia, ice built up on power lines, turning normal maintenance into a dangerous task. Ice on power lines isn't just inconvenient. The extra weight can damage equipment, and removing it usually means workers standing close to frozen, electrified lines in freezing weather. So instead, drones kept people away from the danger completely. One drone used controlled heat to melt the ice. Another knocked it loose using a suspended beam. The idea behind both was simple. Send the machine into the danger and keep the person out of it. Looking at all 3 cases together, the same pattern keeps showing up. The drone isn't there to replace every worker or every machine. It's there to take on the most dangerous or damaging part of the job. In Yunnan, it protected the forest. In Xinjiang, it removed a risky climb across unstable ground. In Hubei, it kept workers away from ice-covered lines. That's why this can't be dismissed as just a flashy demo. These drones are already doing the difficult, costly, and dangerous parts of real infrastructure work. Why America fell behind? Here's the surprising part. The United States wasn't actually behind on this technology. It had a powerful heavy-lift drone years before China's machines became famous. The Common K-MAX, a heavy-lift helicopter, was converted into an unmanned aircraft and used by the U.S. Marine Corps in Afghanistan, where it delivered supplies to remote outposts and proved that autonomous heavy lift could work in places too dangerous for people. The technology was real, and it worked. But after that early success, things slowed down. The K-MAX never became a common tool for civilian construction. It was expensive to maintain, hard to scale up, and stayed mostly limited to military use. Only a small number were ever built before production stopped. China took a different approach. Instead of relying on one large, expensive aircraft for rare missions, it built fleets of smaller heavy-lift drones for everyday civilian work, especially for power grid projects. One country built an impressive machine, the other built an entire market around using it. The difference in regulations widened that gap even further. In the United States, larger drones run into a complicated approval process almost immediately, since bigger aircraft don't fit easily into standard commercial drone rules. Flights beyond direct visual sight can take a long time to get approved. These rules exist for good safety reasons, but every delay makes it harder for companies to gain experience, attract investment, and prove there's real demand. China, on the other hand, has treated drone airspace almost like a new kind of public infrastructure. Licensing, flight paths, and city planning have been developed together, instead of being tested one small program at a time. Shenzhen already runs active drone delivery routes, and other Chinese cities are designing space for drone operations, the same way earlier cities once planned for roads and parking. The message to manufacturers is clear. Build the technology, because the system to support it is already being built. In Western markets, a drone company can have excellent technology and still get stuck in a slow process of approvals, finding customers, arranging insurance, and securing usable test sites. The hardware is only half the challenge. The surrounding system might be the harder half. What this actually changes. This is also why the exaggerated tower crane comparison keeps spreading, even though it isn't literally true. China isn't lifting full cranes around like toys. It's making certain kinds of crane-dependent work less dependent on cranes. A site that once needed a road, a staging area, and a full lifting setup can now receive smaller deliveries directly from the air. That won't replace the massive crane standing next to a skyscraper, but it can completely change how remote towers, power lines, emergency repairs, and mountain construction get done. There's also a more serious side to this. A drone capable of carrying construction material into a remote mountain is just as capable of carrying supplies into a sensitive border area. And larger Chinese drones built with swappable cargo compartments make that overlap between civilian and military use hard to ignore. That's a major reason Chinese drone systems are facing growing scrutiny in the United States. But there's a trade-off. Restricting access to the most affordable, proven systems, while domestic alternatives remain expensive and limited, creates a real gap that policy alone can't solve. China's progress here is still far from finished. Battery limits are real. Strong wind can turn a simple lift into a serious risk. High altitude reduces how much weight a drone can carry, and nearby power lines create their own interference problems. Carrying 100 kilograms is nowhere close to what a full-size crane can lift. Still, the direction is clear. These drones don't need to replace cranes everywhere to matter. They only need to remove the road, the dangerous climb, the cable system, or the extra week of setup. And once that happens, the entire cost of building in remote places starts to change. The next major shift in construction probably won't look like swarms of drones lifting entire skyscrapers through the clouds. It'll look smaller and more practical than that. A drone delivering steel to a tower on a mountain. A drone lowering tools across a river. A drone clearing ice before anyone has to climb up after it. China is already making that routine, while America is still deciding how much of it should be allowed.